Hello, my name is Anthony Mancias, and today I'm going to be talking about the basics of fire behavior in Fire Technology 103. And the first thing I want to talk about is the difference between fire and combustion. So, fire is a rapid, self sustaining oxidation process accompanied by the evolution of heat and light of varying intensities. Combustion is a self-sustaining chemical reaction that yields energy or products that cause further reactions of the same kind. And not to get confused, fire is a form of combustion, and combustion is not a form of fire. It doesn't work the same way. Next, I'm going to explain and talk about the fire triangle and the fire tetrahedron. The fire triangle is a simple model for understanding the ingredients necessary for most fires. The triangle illustrates a fire requires three elements such as heat, fuel, and an oxidizing agent, usually oxygen. The fire is prevented or extinguished by removing any one of them. A fire naturally occurs when the elements are combined in the right mixture. The fire tetrahedron is an addition to the fire triangle. It adds the requirement for the presence of the chemical reaction, which is the process of a fire. Now that we know what causes a fire, I want to talk about what classes there are and how many classes there are, and what determines each class of fire, and also the extinguishing agents that are helpful for each class. Class A fires consist of ordinary combustibles such as wood, paper, carton, textile, and PVC. Class B fires consist of flammable liquid or gaseous fuels such as benzene, gasoline, oil, butane, propane, and natural gases. Class C fires consist of involving energized electrical equipment, often caused by short circuits or overheated electrical cables. Class D combustible metals such as iron, aluminum, sodium, and magnesium. And Class K fires contain a flat elements such as cooking oil. So for each class, there are some helpful extinguishing agents. And for Class A fires, ordinary combustibles, you have water, chemical foam, and dry chemicals. For Class B fires, you have carbon dioxide, halon, dry chemicals, aqueous, film forming foam. For Class C fires, electricity, you have CO2, halons, and dry chemicals. And then for combustible metals, which is Class D fires, you have dry powder, which is suitable for the specific combustible metal involved. And Class K fires, combustible cooking, you have wet chemicals, potassium acetate based. So the next things I want to discuss are the different types of flames or the different types of fires, however you want to put it. There are two primary types of flames. One is the diffusion flame, in which oxidizer and fuel diffuse into one another gradually, and the premix flame, in which the oxidizer and fuel are premixed and the flame is shorter and hotter. Diffusion flames, like those in candles and forest fires, are primarily red or red-orange, reflecting the blackbody emissions of heated soot particles, while premix flames have a closely reflecting the emissions spectrum of the substance being burned, which ranges from yellow to green. Flames result from exothermic chemical reactions, that is, reactions with a net heat output. And last but not least, I'm going to be talking about the different stages of fire. So there are four stages of fire. The first stage is incipient. This first stage begins when heat, oxygen, and a fuel source combine and have a chemical reaction resulting in fire. This is also known as ignition and is usually represented by a very small fire which often and hopefully goes out on its own. Before the following stage before the following stages are reached. Recognizing a fire in this stage provides your best chance at suppression or escape. Then you have the growth stage. The growth stage is where the structure's fire load and oxygen are used as fuel for the fire. There are numerous factors affecting the growth stage, including where the fire started, what combustibles are near it, ceiling height, and the potential for thermal layering. It is during this shortest of the four stages when a deadly flashover can occur, potentially trapping, injuring, or killing firefighters. The third stage is the fully developed stage. When the growth stage has reached its max and all combustible materials have been ignited, a fire is considered fully developed. This is the hottest phase of a fire and the most dangerous for anybody trapped within. Then you have the last stage, which is the decay stage. Usually the longest stage of a fire, the decay stage is characterized a significant decrease in oxygen or fuel, putting an end to the fire. Two common dangers during this stage are first, the existence of non-flaming combustibles, which can potentially start a new fire if not fully extinguished. Second, there is the danger of a backdraft when oxygen is reintroduced into a confined space. So that concludes my video. Again, I'm Anthony Mancias, and thanks for watching.